Welcome back to the Cloud Council. We're talking to senior people who have been there and done that. Our guest is Herman Singh, age 28, an industrial MD, and a man who's very much broken the mold in terms of race, in terms of multiple skill sets, and certainly in terms of his unique strategy of innovating in such a way that he makes his own job obsolete. Plus, in this episode, we're going to look at some of the tech of old and go down memory lane with 3.5-inch hard disks and some of the early iterations of laptop and desktop computers. But Herman, growing up in South Africa, racism must have been not only tangible, but a barrier that you had to overcome.
So look, definitely as a person of color in South Africa, we always felt we had to be better in order to move forward. I remember applying to do my MBA, and the dean said to me at the interview, "Why do you want to do an MBA?" And I said, I'm a person of color. For me to progress in this country, I'm going to need something more that other people don't have. So we were always on the lookout for ways to progress. And I think the thing that became very obvious to me was in those days, if you were in engineering, you probably were not thinking like a businessman. And because of this very unique ability I had, which is I grew up in a business and I studied technology, when I arrived in an engineering company, I found many people were either technologists or accountants, and never the twain shall meet. The entire echelon in most engineering companies was made up of accountants. And so there were very few people that understood how to pull accountancy and engineering together and through, for example, better design, come up with a lower cost and still meet the specification. And so that kind of thinking very quickly demonstrated to me that it was very unique at the time. Very few people were thinking like that. And as the projects got bigger, my ability to influence and shape my career became a lot stronger.
So give us a sense of when this was again, Herman, please.
It was probably in the late 80s. I think it was 89. I was appointed as managing director. I was 28 years old. I was appointed as managing director in the Barlows Group, one of the biggest groups in the world at the time. And I think I was the youngest person ever to become a managing director in those days. And the only reason I became a managing director was because I was able to use math and programming to basically continue to make myself redundant. There were algorithms that needed to be computed, and I would write programs that would automate the algorithms. And there were 4-axis machines that needed to be programmed, and I would write programs to write 4-axis programs. And because I kept making myself redundant in jobs, they kept moving me up the organization. And this concept of make yourself redundant became a kind of theme of mine for a very long time in my career.
So you're almost describing AI, which is a whole rabbit hole we might not have time to go into in this episode. But just for the people watching, can you give us a snapshot in 1989 of the kind of technology landscape, if you like? So we're still talking about a very analog, cabled, non-wireless circumstance. I mean, what were you dealing with at the time?
So, I think in the 1980s, we had the IBM XT, the IBM AT, and so it was the original IBM PC, right? Many people don't realize that every other PC in the world was described as IBM compatible because IBM invented the PC. And so we were working with these IBM machines, which had 286 and 386 processors. The Pentium is like 4 or 5 generations later. And we were trying to design programs that would, for example, do a simulation to calculate the best way to cut pieces of metal, for example. Well, we would load this into a PC. The PC would run for a week before we would get the answers. And if it was wrong, we had to wait another week before we could get the answers again. That just gives you a sense. The data transmission we were working with between our programming workstation and the 4-axis machine was 56 baud rate. Now, 56 baud rate is incredibly slow. It's like 56 bits of information. And you talk about 56 bytes being transferred at a second. 56 kilobits per second is what we had when the internet started kind of 15 years later, right? Or maybe 10 years later, we were working with something a lot faster. And so we were working with punched tape. So in other words, when I'd done my program, I had to take this black tape, run it through a puncher, punch it, roll it up, run into the factory, and get the factory to read it in a tape reader. And so we were using cards and tape readers and this horrible floppy disk. And yet, I mean, believe it or not, we were still using telegrams to communicate overseas. So when I placed orders with England or Japan, I was sending telegrams. I mean, this is insane that the world was at that stage at the time. Fax machines were just coming up.
We are called the Cloud Council, so it's pertinent that I should ask the question. All of this information, the business hub, the kind of the equity in the business was held in your technology and development. Where did you guys store this at the time?
In our heads and books, really. I mean, there was no data storage. Data storage was so expensive. I think the first PC I had to work with had a 5 megabyte hard drive. So you did not store things that you didn't absolutely have to, because it was just, you just didn't have enough RAM and you didn't have enough disk storage to be able to do this. I think I only got my first hard drive 5 years after I got my first PC. We were using double floppy drive machines, as I recall at the time.
It conjures up images of industrial espionage where people are still dipping in and out of offices to try and steal a small disk rather than hack into the systems on a kind of global scale. We've heard more there about your business experience, and in a few moments we're going to hear about how in the industrial sector a digital or a technical problem can literally cost lives. But before that, Herman, we're going to get behind the avatar and find out about this techie's tastes and emotions. Herman Singh, it's time for you to reveal your true, softer inner self. I want to know, what was the last film that you cried at?
Last film that I cried at? My word. It was probably Titanic, I think.
Okay, the next question. If you were fighting for a world title, what music track would be played loudly as you walk out to the ring?
Eye of the Tiger, for sure.
Excellent. And finally, before flying into space with Elon Musk and living on the International Space Station, eating rehydrated protein bars, what three-course meal are you going to enjoy before liftoff?
Probably a medium steak, preceded by a nice salmon salad and a creme brulee.
Creme brulee, he hits creme brulee. That's your triumvirate. Thank you, Herman Singh. Now, we're smiling. Technology is both fascinating to you and it's proved to be a great factor in your success. But you have referred to how in the industrial world, as opposed to the commercial world, when things go wrong, it's not just costing profit or revenue, it's costing lives. And you had a fairly challenging experience when you were at, I believe, Siemens?
Yes. I was a managing director of Siemens, and South African law, and I think law in most countries, engineering companies, the managing director or the CEO is legally accountable and responsible. It's called the legally responsible person. And the word here is responsible, meaning if somebody dies on your watch, you are legally responsible for that death. And so we recognize that in engineering, you had to design things so robustly that failure was almost never an option. We had lockouts, safeties, backups, redundancies for everything. If we were designing a mine winder, the cable would be 10 times stronger than it needed to be because we just didn't want to take a chance that the cable would snap. Our gold mines are 5 kilometers down. That's a long way to fall, right? And so, we were, if you're designing big electrical systems, I worked on pipelines, these things can be very dangerous. And so we definitely had 2 people die while I was managing director. And it was awful. The one situation was we were basically automating an oil pipeline from the coast up to Johannesburg, which is inland. And the interlocks failed and we had oil in a place we shouldn't have had oil. And somebody switched the electricity on and we had a fire. And it's actually quite amazing because when we moved into commercial, when I moved into commercial, I took a lot of that thinking with me. And so we started building commercial systems the way we built industrial systems, which is, it's the way you build aeronautical systems. You design them, you got multiple redundancies because if something goes wrong, people die. And so although that's not true for commercial systems, you build them as if that's true. And so I think commercial systems have benefited strongly from the application of industrial type thinking.
Do you think automation in the modern era often removes developers and coders' rigor when it comes to that kind of thing? And how can they, maybe find that or get it back? Because at the moment everything seems to be, coded, and the detachment is very real in the same way as an industrial environment. The physical is very real. How can we maybe revisit that, or what would you advise young technologists?
Look, firstly, I think the technology is a lot more fault tolerant now. It's harder to make a mistake. Secondly, I think it's easier to run emulators so that you can do much better testing. You've got robotic testing systems that you can run now. You can actually emulate the environment that the system is going to be running in. We never had that option when we were programming. And again, of course, if there is a failure, often there isn't a huge amount of issues where there's serious consequences. Today, you can do things like unit testing, reverse testing, acceptance testing, integration testing, full system testing, thin slice testing. We never had any of these things. And the ability to do all of that, I think, is a huge help. I really think that the one big thing that engineers have today going for them is, because we use agile and sprints, we tend to build code in smaller lumps. And so in the past, we would build this monolithic system. It was a system to control a gold mine winder, and the entire thing had to be tested in one go. Today, you can build small elements of it, test it, and then move on to the next sprint.
Well, I know that in the next episode, you're going to share with us some of your experiences about moving into the commercial world, and how particularly we're going to look at some of the digital companies and how they've risen to such prominence, and also understand from your engineering background how running simulations have accelerated a large proportion of your work in the commercial world. And obviously, we'd love to hear your views on digital transformation. But Herman, for now, thank you very much for joining us. And anybody watching, we sincerely hope you'll join us on the Cloud Council for the next in-depth conversation with Herman Singh.